accommodate to be able to encapsulate all this.
What if your intent was not to lock it up, but now it's locked up? No matter
Yep,
what?
now it's locked up.
So
So,
you have to change
so sometimes they can change the design at the top side, but for the monies it would cost to do that, it probably wouldn't be feasible. So they may do something on the other end of the bridge to account for this. Maybe make a bigger area on the other side so all the movement's on one end and not both ends.
Just tell them to pull the piling back out and do it again.
I agree, that's what I would do.
Yeah, that's
That's,
pretty
you, Mr. Contractor, either that, you're not getting paid for it, all the extra rebar and concrete's at your expense. Right? Yep. And, so yeah, it stuffs, it happens in the field. You know? You know, and maybe, what was that other thing we
What
talked
was the
about?
inspector doing
Why did we
this?
let them do that?
Why did they keep going, right?
That's what your engineer's gonna ask you, how did they get this far?
Right? What do you think about pre-boring? Do you think that maybe would have helped the situation? Yeah, we're only free, let's say free up to 8 feet, but maybe they gotta go 15 feet. You think that would have been a better solution maybe after the first piling? Okay, maybe let's run a drill rig and
Do you think they probably were going to look at rock twisted that?
it's not so much bedrock. When you hit bedrock, it stops right now. So what happens when they're driving this, there could be boulders this big around down there, and it's hitting them and then piling are going like that. They're going all different directions. I guarantee them piling are not straight at 85 feet. They're hitting something and they're walking, so when so say you got a boulder this big, and you're driving it down on top of a rock, if that can't break through that rock, it's gonna go just like this, until it gets to at least past the resistance. And then they walk. Oops. Right? The crane operator was busy trying to keep it straight. Yep. Same scenario. You know, I talked about, we said this is an integral abutment, the weak way. You had all your piling in a nice straight line, but you orientated all your piling wrong. I'm not one to, you know, it's fun to talk about, but I will never demeanor anybody for it, because it can happen to anybody. Anything. There's a abutment with a crash wall, railroad crash wall, 6 feet out of elevation. Wrong way of the line. It happens. We just pay for it, we fix it, we move on. Let's learn from it. I guarantee the inspector will never do that trick. He's gonna look at every elevation. So pile vents, meaning the common characteristics, driving a single row, they're capped with timber, steel, or concrete caps, and they're driven to closer tolerances than a standard footing is. We cut everything in half for pile vents. These are the exposed piles you see usually on townships, counties, where your piling is exposed. And then you have the cap on top of it. So now we cut them in half. What did we say for our standard foundation? What was our tolerance? 1/2 inch. Pile vents are 1/4 inch. Final position, 3 inches. That's half. So I showed you pictures earlier of templates. We'll see more templates coming up. So here you can see, there's your typical pile vent, exposed piles with the cap on. There's templates. Look at it, working out the river, working off barges. Look at that nice template they got. Look how straight that is. It can be done. Contractor has to pay attention to what he's doing. But there's a close-up of our templates. On floating barges, probably got spud bars, going, they're connected to the bar, brick brackets, stick them in the ground to hold the barge in place, and then they weld these templates, everything to the barges, to make their nice straight line. Gotta watch out for obstacles. You got a power line, but what I can't figure out is, why would you encase the top line and not the bottom line? Or both of them. And you can see we're not wearing life jackets. Follow your contractor, the other contractors, their safety plan is. MnDOT has our safety plan. Usually contractors a little more stringent. Same thing, you can see the tops are galvanized, we're putting bottoms in, ungalvanized, we weld the galvanized piece on after the bottoms are in. And this is another good scenario for your test pile. So say you drive a bottom in, and your bottom stops right here. What do? Our next piece is galvanized. We only got half the pile galvanized. What do you think we should do? What are some options? How do we correct that? How about we cut the piling off as deep as we can, weld on the galvanized piece. So this also determines here is maybe if we're stopping right here at this elevation with our test pile, maybe we gotta cut 20 feet off our bottoms to get the galvanized into the ground. That's another important thing for test piles, to determine where your galvanized line is gonna be. You may have to make some adjustments on your bottoms. Equip every pile with a shoe, welded watertight and no greater than 1/4 inch in diameter. This is probably the only place this says that. It does not say anything in your plan sheets about a shoe. It would specifically say a cone or a tip protection, some sort of thing, if it was a pay item. But every pile gets a plate on the end. Every shell pile gets a plate on the end. Just like that. They can be welded in the field, they can be welded at the factory, or they show up. But every pile, unless it states otherwise, gets a shoe on it. Or a plate. Just a picture of a welder in the field, put the bottoms on.
So requirement for the rise?
We'll get into that later on. Yes, I have a whole spiel on welding and welding rods. We want to look at every pile after it's driven. This is where we want to drop the tape measure down the inside to make sure it matches what we started with your inside dimension. Another thing works great, a mirror. If you guys are at truck stations, go over to the maintenance side and get you a little mirror. That's the best flashlight you can get on a sunny day to see all the way down to the bottom of the pile. You can see if it's crushed, bent, kinked, anything like that. So if you had a 60-foot piece of pile that you started with, you dropped a tape measure in there, and now it only says 40 feet. What do you think? Each one of them folds is 6 inches. Where was the inspector on this one? You know, something's happening. When you're driving, when you've driven a lot of pile, you understand and you learn about how a hammer sounds and when it's driving and stuff. You see it in your measurements of your stroke height. You can identify this kind of stuff that's going on down there. So this plan called for this special cutting end on there. And this still got the plate, and then they had to put this cutting shoe on. But that can happen. You can accordion a pile. I showed you these already. That's what, if you look down the inside of it, that's what the accordion would look like. And again, it's a bent pile. Same thing. We talked about the H pile, least path to resistance. These guys do the same thing. They can be going down, hit a boulder this big. Can't move it, can't push it, so it's just going to go right off the side and start going down. So what'd you pay for this pile? That's an inspector.
Because, where it is above ground.
This is 62 feet down. But you paid for that pile. What was our requirement? What did we say? Oh, maybe I didn't get that far. Because I didn't say it yet. But it's a damaged pile. We consider that a damaged pile, right? Do we pay for damaged material for anything damaged on a project? Agreed. We wouldn't pay for this. But then again, same conversation. Who do we call? Engineer.
Did they actually read
So generally what they would do, if this is a damaged pile, we don't pay for it, the contractor is required to give us another pile, a good pile. So what they would do is just, if you look down there, the pile went that way, they're gonna move over a foot or two and drag a second pile right next to it to cover for this. What's that?
They just fill it like here, or they take it out?
Nope, they would just leave it, just abandon it, fill it, put dirt, concrete, and just abandon it, because it wouldn't be part. There is a value to it, but we cannot determine the value. As when I say value, I guess I'm saying there is structural value, not monetary. There is structural value to that, but how do we measure that? So we just eliminate that. Yep. And you see any other problems if you're gonna try to measure that? How many pile do you think of each tape measures? You got a nice little weighted thing on the end, a bolt, nut, whatever you put, and you just squeeze it right there. Just a tape measure. Cones. Talked about cones a little bit. If you have anything other than a flat plate on a shell pile, it's a pay item. So, if you have fresh concrete in the area, you're not driving piling in that area. Do not place concrete for footings caps until the day after concrete placement for pile fill. Generally, that's a free-for-all because they'll drag the pile, do the pile fill, and it's usually a day or two to set up forms anyway, so there's usually no rush about that. The old-fashioned way, we can still do it. The old water bottle, put it on the ground next to it, look for ripples, see how far away your vibrations are for fresh concrete. But now in our new spec book, we have the guidance for sizing equipment and how close they can be for vibrations for concrete. We want to protect our piles from freezing when we pour fresh concrete. Hot off the press, we're revamping this statement right here as far as the 30% cement. This has been in here forever, and with the new mix designs, contractor mix designs, the concrete office is not allowing this additional 30% without new mix design. So being what we do today with heating and housing, it's more convenient, it's more accessible. We're just gonna delete that because everything's gotta be above freezing when we pour concrete in. So, what about using air and train concrete and pile vents? Do we, don't we?
Yeah.
Oh yeah. Why wouldn't you?
Because the spec book says we don't have to.
Right, the spec book says we don't have to, but let's look at common sense. Freeze thaw, wouldn't you think you'd want to use it? But yep, she's right. In the spec book, we have 1P pile fill. That's it, non-air. Some people, some counties, they insist on it. They'll pour the bottoms with non-air train and then cap up 10 feet below grade and then put air train. That's at their discretion. When we talk about protection against freezing, you know, it's probably not too cold in this picture. It's in the future if you haven't noticed. But they just blanket them up, put a little heater in there. Want to keep it from freezing. We have requirements for rebar and a foundation, you know, before you pour concrete. It's got to be above 40 degrees and maintained above during the duration of the cure. Simple examples, you know, maybe it gets down to 30 degrees at night, but it's 50s during the day. Something as simple as just putting some blankets down might be enough, because you got your radiant heat coming up out of your piles. 50, 60 feet down, that might give you enough heat in there. So you pour your concrete in there, and you cover them back up, and you let them sit for 3 days. Provide pile tip protection if required by the contract. How do we know if it's required by the contract? It's a pay item. Other than what? What don't we pay for? The plate, the flat plate and the tip. Close up of our hardened tip of A&H pile. Again, they can be welded in the field, welded at the factory. Look at our little sticker right here. What's that tell us? Heat numbers. What are these numbers? So if this label's gone, and you have this label on here, and this correlates two numbers on your mill cert, would you accept it? Sure you would. As of today, yes. Coming down the pipeline, maybe not. But as of today, crayon marking is perfectly acceptable, because you'll get cutoffs that the contractor is gonna use for the surplus for allowed up to 5%. We may not have that original sticker on it. We may have crayon marks on it, right? But if we have a piling that's been sitting out in the weather, you can tell there's surface rust, flaking, scaling, and then there's a fresh crayon mark on there with a brand new heat number. Would you use it? You know something's funny here. And the other thing, this just happened not too long ago. Got some heat numbers for piling, got the mill cert, and the piling, the surface rust, been sitting around for a long time. You can tell by the mill scale, flaking. The mill cert was from that same day. Something's fishy here, guys, right? You know? Gotta play the contractor's game, you wanna catch them. Talk about setup again. If you're driving a pile, you have 80 feet in the ground, and you're so close to meeting requirement, but you're not quite there, we can stop and wait for 24 hours to do is let the soils grab that and do a redrive to see what our setup is. I'll talk more about that a little later on, how we do all that. If your contractor includes a pay item pile redrive, it'll specify a duration, 24 hours, 36 hours, 48 hours, 72 hours. It'll specify a duration before you do your redrive. And if this is in your pay item, it does not mean you have to use it. If you met your bearing requirement, you do not have to use it. If you did not meet your bearing requirement, and you're that close, say it calls for 80 feet, you're at the end, then you can then use it. Why add on 10 more feet, 20 more feet, and keep driving? That's our next step. Let's wait and see if we can get it for setup. And if it is not on your plan sheet of pile redrive, and you drove that 80-foot stick, and you're at 78 feet, and you're so close, but you're not gonna make it, you can use pile redrive. Just because it's not on there, doesn't mean you can't use it. Just write a change order. Yes, sir.
Question, so we did a triple box culvert, we had over 400 pile, because it's just typical new shit.
Yep.
Does it matter, I can't remember, I think it said 24 hours for the redrive, but there was some we did on a Friday, we just let them sit, we had a holiday in the winter, and we just let them sit for the whole 3 days.
Yep.
Make a difference.
Nope, that's perfectly acceptable, because from when you drove on Friday, when you stopped driving, you had a bearing, say you had 100 tons, and when you came back on Monday, you had 200 tons. So you'd have 100 to 200 ton% increase. You would have that increase that you could apply to the rest of your piling drive. Meaning, you can drive all your other piling to 100 tons, because you know in 3 days it's gonna hit 200 tons. You prove that. That's what the redrive does. Remolding mechanisms of pile setup, I kind of explained that a little bit. Remolding of the soils, grabbing onto the pile. We don't account for it in the design, it's just cost-effective results that we can do to reduce pile length in the ground. So if we look in our plans or special provisions, drive to about pile length, wait 24 hours, redrive, call bridge office. If capacity was still not achieved, continue driving test pile to full length. So you'll have a plan note in your plans that says drive test pile to foundation length. Stop, wait 24 hours, and do a redrive. Because they're expecting you may get pile set up at foundation length. All your test piles will always be 10 feet longer than a foundation pile. So when it says that in your plan, that's what you do. Drive it to elevate, or to your foundation length, wait 24 hours, and then come back to redrive to see what your setup is. You may get more setup than you need, you'll meet your requirement, and you may not get setup. There may not be setup. And when you're driving pile, if you've been driving pile for 20 years, half your life, you would know when you got down to 70 feet, and a good assumption is 20% increase, you can say, no, we're not gonna make it. We're only at 30 blows per foot, and we need 160. You know at 70 feet you're not gonna get it. So you're probably gonna continue driving a little further until that MC start increasing on your capacity on there. Schedule quantities. Pile redriving. Calls for 18, I have 18 redrives on this project, 27,138. If I need them, I use them, I pay for them. If I don't need them, I don't use them, I don't pay for them. Simple as that. So when we're waiting this 24-hour period for setup, we're not allowed to drive other piling in the substructure, in that same substructure. You may be on a wall, a retaining wall, where you have piling for a mile long, and your test pile's allotted every couple hundred feet, and you have a redrive on all of them, and they're 50, 100 feet apart. You can drive your first one, go 100 feet, 200 feet, do the next one. We just don't want two pilings driven in the same foundation, 40, 50 feet in the same group. Because if you're driving your test pile here, and you do a foundation pile here, that'll be enough vibration that could send it over, and the soils don't have that time to relax to grab that pile. So that's why we limit that when you drive a test pile, you're waiting 24 hours not to drive other piling in that foundation. And the contractor bids it that way. But again, if we drive that pile and we get to bearing without redrive, are we gonna pay for it? No, because we didn't do a redrive. And the other big thing is, when you come back and do a redrive, you wanna start it up on a timber mat, another pile, something else, so when you put it on your redrive, the hammer starts right away. We don't wanna be priming the hammer, trying to get it started. It takes 5 blows to get it started, start and stop. Because now you probably vibrated the soils enough and released the pile, and it could take off on you. So we want to do the minimum amount of blows that we have to on this pile so it doesn't take off. We don't trim our piles until the engineer determines cutoff elevations. All the piling has been accepted. Penetration and bearing. Department calculated the minimum required nominal bearing resistance shown in the plans. You have to accept the pile at a minimum of that bearing requirement, nothing less. And then, regardless of the value measured during driving, the value of est used in the formula shall not be less than 180 blows per foot. So, here's our first look at the plan sheet. So if we look on sheet 20A, I think it is. So when we look at the computed pile load, tons per pile, 3 across the top, right? That's the design criteria that the designer needs for load for his pile. That has nothing to do with their bearing requirements during driving. It's just the load table that the engineer says, my piling need to hold up this much load. Okay? So then if we go down to the chart underneath that, let's look at north abutment. Factor design load, what's that number? Factor design load? 83.2. Now we're going to go down to our north abutment required nominal pile driving resistance, or bearing resistance, R little n. So when we talk about tons, bearing, driving, piling, this is what we talk about, this lower table. Us as an inspector, don't look at this table yet. Give yourself some time to understand this first before we look at this. But how that works right now is you take this 83.2, and we have a fee factor. Right there, 0.5, which then multiply that by that, gives us that for a nominal bearing requirement. So it tells us right here, required nominal pile bearing resistance, tons pile, right? What's this tell us right here? Nominal resistance, nominal resistance, nominal resistance. MnDOT formula, bearing requirement, right here. So if we drive this pile, our first pile, I'm gonna say foundation pile. What are we gonna drive it to for bearing requirement? Tons. Foundation pile. Because I haven't told you about the
163.1.
agreed, right? That tells us right there, when we drive a pile, nominal resistance, everything we look at in our formula, which we haven't seen yet, it's gonna be RN, nominal resistance. It doesn't say up here, right? There's no nominal resistance here, nothing, right? Nominal resistance, MnDOT formula. Nominal resistance, MnDOT formula, nominal resistance, right? So if we look at the wing walls, what are we gonna drive our production pile to? 148.6. So, when we look at this now, Paul just talked about it this morning. Our north abutment, we're gonna drive piling to 166.4 tons. I think that's wrong, it's 164. Okay. And then our south abutment's gonna be 162.2. Why do you think we have a difference? Nope.
Family.
Span length. Different span lengths, therefore different bearing. So we got a span length of 124 feet, 124 feet, 4.5 inches. You got a span length of 139.5. Right? So if we look back, we went up here to our pile load table. There's a difference in our load, right? Which transcribes down to this. Everybody following along? Anybody lost? Need some clarification? We're only gonna get deeper as this goes along. Sure,
I have a question.
sure.
So is it normal when the PDA comes back that they'll give you like a depth that's required, and then it says +2 feet? So once you get like a PDA, there's like a bearing table,
Yep,
once you get bearing, you gotta have it, so you gotta have it 2 times,
yep,
and then they said you gotta go additional 2 feet
yep,
after you hit that, is that normal?
yep, that happens.
Oh,
Not all the time, not every project does that, but yes, that does happen.
okay.
And we'll talk about PDAs coming up here yet. So don't get confused with this with PDA. So we want to drive the test pile full length, unless you hit substantial refusal. What's our substantial refusal? 0.05 per, how many?
Per blow. 0.05 per blow.
0.05 per blow. 0.5 per 10 blows. Remember, we gotta keep blows and per 10 blows, know what we're looking at talking about, okay? So that's the intent of the test pile, full length, unless you hit substantial refusal. Okay? What's that tell us right there? Am I blocking you? I should go stand up for a second. What's that tell me? What am I gonna do with my test pile?
$191.26 on the north.
Okay, back up and tell me what are we gonna do? What does this statement say? I totally agree with you. So what this statement is telling us, when we drive a test pile, we are gonna drive it 115% of nominal, right? RN, nominal resistance, bearing tons. So, we're gonna take this number plus 115%. I don't care how you do it, multiply it. No, I guess it's not here. It's coming. So 115% more, great. So, if my bearing requirement's 166.4 for a foundation, what's my test pile?
191.
That number times 1.15.
There you go. That number times 1.15. I got another slide coming up somewhere, shows math. I don't care how you do your math, you're gonna get the same result. But we wanna do 115% on all test piles. So you might wanna highlight that in your spec. That's the only place that's gonna say 115%. Nowhere on any plan sheet or special provisions does it say 115%. That's just normal practice. If you've been driving pile for a while, test pile goes 115%. We're gonna drive it full length unless we hit what? Perfect, two answers. Bearing, full length, unless we hit substantial refusal. And then at the end of the drive, we have to have what requirement? Minimum. You said it once. Bearing, right? We gotta have bearing when we stop driving. At a minimum. Okay, everybody following along? Doing good? What's that? Respectful.
Page 419.
Right there. We can take, let's take a minute and see, let's find it. I don't have it. I have it coming up in some slides, but let's find it. Right there, second paragraph down, page 459. 115% for your test pile. So when there's a test question that asks you, what are you going to drive your test pile to? What are we going to drive it to? 115%. We've harped on this. Substantial refusal, 240 blows per foot. And look at it. Now I put it in ½ inch and 10 blows. It's the same thing as 0.05 per blow. So, in our plan sheet, we go back. We have a MnDOT formula, and we have PDA, right? There's two ways to measure piling. If your plan sheet has a pay item for PDA, the contractor will use a PDA, pile driving analyzer. If your contract does not have PDA, and the contractor elects to use it, he can do a PDA at his cost. We will not pay for that PDA. We'll get in more into PDAs too. So, contract item, we pay for it. If it's not a contract item, we do not pay for it. So if we're using PDA, what are we driving our bearing, our foundation pile to? What bearing? Agreed. Remember, just look at this. Nominal resistance, MnDOT formula bearing, PDA bearing. So this is your PDA. PDA professional, expert, is going to come out, drill and tap some sensors right onto that pile. And he's gonna read actual live data as this piling's being driven. He can measure the forces, the stresses that's being put on that pile during actual raw footage. Remember, we did the WEEP analysis, and we're assuming everything, because it's computer generated. So with PDA, it's actual live results. Hence, when you look at that table, how much less are we driving piling? The variance, for variance. MPF versus PDA. What's the difference in that measure? Almost 40 ton difference, right? So, when you have a project with lots of piling, 50, 100 plus piling on a project, and we don't call for a PDA, the contractor may elect to do a PDA because he can save on piling length on his piling. He won't have to drive them as deep. So if I can save 10 feet of piling on 100 piling, what do you think my cost savings is? It's a lot, right? So, sure, Mr. Contractor, go for it. We'll let you use a PDA. But we won't pay for it. If it's not a pay item, we don't pay for it. Here we go. Here's our first look at the MnDOT MPF12 formula. What do you think? Easy? Any mathematicians in here? Statisticians? Ooh.
I wanna know why there's not a lot chart for this.
What's that? Ooh. So we can come to you for answers. So there we go. So what is our formula? Look at nominal piling resistance in tons. Where did we see that before? Where was that? Plain sheet, right? Right there's our formula, RN, nominal resistance. We call it bearing, we call it tons. Nominal resistance. W, the weight of the striking part of the hammer, or the ram in pounds, that's the ram that goes up and down inside of there, times the height of the fall. What did that give us? Anybody remember? And the energy, right? Weight times W times H gives us the energy. S is our average penetration in inches per blow for the last 10 blows. Okay. And you can interpolate, if you do 20 blows, you can interpolate it. When you do a redrive, sometimes you do 5 blows. You can interpolate 5 blows to 10 blows. Pretty simple. Okay. W times 8 is measured during driving. When we get going down the road here, we'll talk about how we measure the height of the fall, things like that. W times H is our energy. It doesn't work, this formula doesn't work. And the average penetration during driving is 0.5 inches per blow, or less than 24 blows per foot. What did we say on our WEEP analysis? What was our blow count requirement? 30 to 180, right? So this formula is set up for 24, but our driving criteria that we're saying is 30, okay? Don't get them confused. So if he's driving his piling and his average penetration during driving is less than 0.5 inches, we have some options. We can reduce our fuel setting to hammer. What did we prove when we reduced the fuel setting? What does that do? Reduces our energy, right? Perform redrives on test piles and 10% of the foundation piles that reduce fuel settings in the hammer. Or do we continue driving until our penetration is less than 0.5 inches per blow? Or use a smaller hammer. We're not changing contractor means and methods, it's just a simple adjustment on the pile hammer, and we don't compensate for that. So here's our PDA. So when the contractor does our PDA, comes out, he records the live data, he goes back to the office, puts it in his special program, and he's gonna spit out a piece of paper that says, this is your driving criteria. It's that simple. I'm a fan of PDAs, I love PDAs because it tells me what I'm gonna drive a pile to. Okay? This is my safety spiel about bridge building, pile driving, anything. You as an inspector There is no need for you to be down in this hole when they're cutting piling. You don't know where this piling is gonna fall when he's cutting that. You don't know what directions it's gonna go. The guy cutting it, he has intentions, he knows where it's gonna go. But you as an inspector, stay out of this hole. There's no reason for you to be in here. What do you think these numbers are? 97, 98, 99, 100.
Pile number.
So there's numbering pile. So you as the inspector, you got all these tops on here. The contractor goes down and marks cutoffs. So you as the inspector, you've been keeping track on your tally sheet, on your pile driving report, right? You've been numbering piling, things like that. You're gonna go down there and number your piling below the cutoff and above the cutoff. So when they cut that off and they swing that piece of pile over in a safe location, you can look at your number. I cut off pile 99, I cut off 10.2 feet. I put that on my report, say pile 99, I cut off 10.2 feet. So I know to keep track of my pile cut. But again, there is no reason for you guys to be in this hole when you're cutting pile. Any other operation, ever driving piling, you can be up close and personal by pile. It ain't gonna hurt you. You're gonna get dirty, but it ain't gonna hurt you. Again, mark the piles before they cut them off so you can measure them when they're stockpiled. Stay away from cutoffs. Splices on H piles and CIP piles. You've seen it on the plan sheet. Farther back, you have a standard plan sheet. Shows you how to splice a pile. Welders have to meet the AWS D1.1 continuity records. On Friday, I have a cheat sheet. It's on the website for welder, checking your welder qualification. I will cover that then. I'm not going to talk too much about that. Make splices on piles driven in pile vents at points not exposed to view. You don't want to splice a pile where it's always going to be in view. But if for some reason it is, or if you have a spiral welded pipe, the contractor needs to grind all that stuff smooth. It all has to be uniform surface. You don't want beads of weld sticking out, protruding. Grind it all smooth. Commercial dry fit splices. They can be used except in these conditions, right there. So if they show up on your project, pile splice looks something like that, make sure that he's within all the rules to be able to use that. And reference your spec, what it says if you can use it. Generally, your special provisions will have a statement saying that these are not allowed to be used on this project. But if you ever see them, double check, triple check to make sure you can even use them. We don't see too much of them anymore. So there's your pile vents. One spot we can't use them, commercial splice rings. They have to be welded, the pile has to be welded. It's just a friction fit. They put the bottom piece in, they slip the ring on, they put the next piece in, and they keep driving. There's no welding, no nothing, they just put it together and keep driving. And that's where it's important, you know, if you have abutment that's moving, you have uplift forces, it'll pull it right out of that stuff. So we can't use it in those conditions. Large CIP piling projects. Here's an example. You got a big line, hundreds of pile. This would be a good case, you know, we could use a PDA. Let's reduce some length of pile lengths. How long do you suppose these are? 50, looks like a 50 there. You know, if you're doing that much piling, you save 10, 20 feet, that's huge. So there's the detail on the back, B201 and B202. B201 is shell pile, B202 is H pile. But there's your detail using a backer ring, bevel, ground bevel, and then welded. And it tells you the directions here, what welding rods they can use. Installing the backup for the chill ring, that's this ring right here. Splice ring, backup ring, chill ring. Put it in there, they tack it into place. These welded are into place. They splice the next piece on, and then they weld that. So when I talked about visual welding, need to be ground smooth, this is it. This is a spiral welded, look at the slag chunks on it. It all has to, anything that's visible needs to be ground smooth. There he's finishing up his welds. He's going on to the next chill ring, or the backer ring. H-pile, he's using some C-clamps to try to get everything aligned to weld that. And they're welding this, this summer, last summer, contractor was fussing because he thought he only had to weld one side of this whole pile. If you look at the detail B202, it's 100% weld, meaning you go around the whole perimeter of that. You don't just weld one side, you go around the whole perimeter. Weld that. Look at there. There's our label for our heat number, the trace it. Painting piles, organic zinc rich paint. If it calls out in your plan, generally these pile vents, they're zinc painted. You've got to paint the entire section of pile that extends below concrete and above ground or surface with zinc rich primer. Continuously coated. Minimum of 10 feet below ground line it has to be coated. Define ground line. You know, the water line, ground line, whatever. 10 feet below that, that's where we want it going. And that's why it's important when we do a test pile, so we can determine that we meet this requirement, that galvanized is gonna make it 10 feet below the ground line. And where I talk, you know, you may have to adjust your bottoms of your piling so you can meet that requirement. So here's your galvanized pile. And again, we wanna use proper rigging, so we're not scratching and wrecking the coating. What kind of pile is this? It's a test pile. Who lays that out and labels that? Inspector does. Some new inspectors, they'll label these just like this, and they'll label their production pile. Until they're comfortable, they know what's going on, they know where they're at in the world at all times. It's one thing important when you're driving piling. You always want to know what elevation you're standing at, and at any given time you want to know where the tip of your pile's at during driving. So there's your spiral weld. Again, look at the nice straight line of that pile bent. There you can see we're grinding nice and smooth before they get coated. Ooh, look at what happened here. What would we do in this circumstance? Kind of looks like you may be in a cofferdam if we look at a shadow here, all right? What are we gonna do? Oh, you can do better than that before you call the engineer. What should we do? Would we accept that pile? No. So what are we gonna do? What are some options? If this, let's say this is in a cofferdam, I know it's in a cofferdam, there's 5 feet of water and it collapsed right there. What can we do? Pump it out and then do what? Cut it, splice on, let's go again. Just because you damaged it there above ground doesn't mean the whole pile's junk. Let's cut it off, re-splice onto it, and continue driving. There, they pump the water out, they cut it off right there, and they spliced a new piece on. Continue driving. They probably pumped it out sooner than they wanted to, but that saved the pile. Special care handling, again, use proper rigging, blocking, don't drag them through the rocks. And then when you fill them with concrete or you're doing your pier cap pours, wash the slurries off so they're not stained and burned up. Metallizing, that's the word I was looking for. Metallizing. For back there, I had a question about galvanizing. It's called metallizing. Use hot zinc stick. Zinc rich paint is not acceptable repair. What other kind of rattle cans can we use for it? Where are we not allowed to use rattle cans? Rebar, epoxy rebar, right? Splicing. Trying to hurry up and get through this before all this stuff. So if you have a splice, you're required to make a splice beyond foundation length, test pile length. We pay for a splice at 6 times the foundation length of the pile. Meaning, what did we say? How do we pay for a test pile? Each. How do we pay for production pile? Linear foot. So when we're figuring out how do we pay for splice, or the rate we pay for a splice, so for a test pile or a production pile, we need to figure out the footage rate for a production pile. How much did the contractor bid per foot of production pile? And then that's the number we take, multiplied by 6 to pay for a splice on a test pile or foundation pile. Because remember, we paid for a foundation. How do we pay? We're not going to pay for a test pile 6 times for one splice, right? So we got to take our foundation footage length multiplied by 6 for a splice. We will only pay for a maximum of 1 splice per pile, and we do not pay for the splicing the contractor needs to make up a pile. So if the plan sheet says contractor supplies 70 foot, if the contractor has to weld 3 pieces to get to 70 foot, we do not pay for them splices, okay? So, hope you understand splicing. So my plan calls for an 80-foot test pile, 70-foot production pile, and the contractor brings 40-foot piles on site, okay? We drove to the test pile to 78 feet. Do we pay for a pile splice? No, agreed. Production pile was driven to 70 feet. Do we pay for a splice? I see some yeses. I see some no's. Why?
Total we needed 70.
Okay. But the contractor brought, how long? Contractor brought 40s, right? So if I weld 2 40s together, what's my length? 80, right? So I drove my production pile to 70 feet. Do I pay for a splice? Because the contractor's required, if the plan calls for an 80-foot and a 70-foot, at a minimum, the contractor's required to supply those lengths, no splices, okay? No, we do not, on production pile, we do not, because he has to give you a 70-foot piece of pile, period. 90. We'll get there, okay? So remember, a test pile is our feeler pile. We want to see, compare our boring logs, how the drivings to the weep analysis and everything, how it's actually going to drive. Okay, same scenario. Plan calls for 80 test, 70-foot production. Contractor brings 40-foot piles. Drove the test pile to 78 feet. Do we pay for a splice? No. Drove production piles to 78 feet.
Yeah.
How do you pay for a splice? No. So if the contractor brings 40-foot sticks, he has to put 2 together to get to 70, right? Minimum. But it just happened to be, he brought 2 40s to give me 80 feet. So I have free pile driving up to 80 feet. If I go beyond 80 feet, then I pay for a splice. Because he supplied me with 80-foot pile, right? Okay? Clear as mud? Plan calls for 80, test is 70. Contractor brings 40-foot piles and 30-foot piles. So we drove the test pile to 79 feet. Do we pay for a splice? Nope, because we called for 80 feet, he has to supply us, he probably welded 2 40s, right? To give me 80 feet. Production pile driven to 69 feet. Any combination of would we pay for a splice? Agreed. Because he could have welded a 40 and a 30 together to give me 70 feet, He could have welded 3 30s together to give me 90 feet, because he has to give me 70. I need 70 feet minimum, Mr. Contractor. My plan says 70 feet. You give me 70 feet for free. I pay for no splices up to 70 feet. So, except one production pile is driven to 76 feet. How many splices do we pay for? Do we pay for splices?
Depends on what you put together.
Depends.
What do you think?
So could he game the system on that one?
Actually,
Nope. Well, he could,
Could.
well, but
If you put 70 feet together,
if he's got 40s and 30s, how does he play the game? He can't play the game.
But you can't put as low as
Right.
10 feet.
You can.
if you expected to go to 69 feet, and put the 70 together, and you didn't get bearing, and you had to put on more, then you pay for splice.
Perfect. Makes sense? So if Mr. Contractor puts a 40 and a 30 together, that's 70 feet production, right? So, contractor, I'm gonna put 70 feet together to give me a production. So I drove at 70 feet, I did not meet my bearing requirement, okay? I have to add on. I provided you with 70 feet, I'm going beyond 70 feet, I paid for a splice, using a 40 and a 30, okay? Make sense? What if I welded 2 40s together in that scenario?
No.
You don't pay for it, because he gave you the 70 feet plus 10 extra feet free. So he's got 80 feet in the lead, he just happened to drive it to 76. Nope, you don't pay for the splice. So that's where it's important, you have to pay attention when you're keeping track on your log, your driving log here, driving report, is the length of the pieces he's putting together, so if he's authorized or if you pay for a splice. So any questions on how paying for piling, for splices? Yes, sir?
Can you tell them what lengths you can use?
Nope.
So if you drive a pile to 76 and he put a 40 and a 30 together, and you had to add more, can you then have him put 2 40s together?
Nope, you cannot dictate to tell him what to put together. He may, what he might do though, if he's got cutoffs, so he drove one to 69 feet, so and he had 80 feet in the lead, so he's got 11-foot cutoff, okay? So he's probably gonna put that 11-foot cutoff on that pile.
Okay.
And then, okay, so he puts that 11 feet on, he drives that 11 feet in. We didn't get bearing. Now what?
That's all I was wondering, is if you could play the game where you're going slightly over 70 every time, and instead of putting, you know, you kept ending up at 76, he kept putting 40s and 30s together to get to 70, so that he could add splices, or?
There's maybe 1 or 2 contractors that play that game, because the contractor's looking at production.
Yeah.
He's trying to get piling in, he's got a schedule. You may, like I said, you may get 1 or 2, but you can always have the conversation with them. Really, we've proven that these are going deeper, why are we not putting deeper? Yep.
I suppose if you wanted to fight that, you'd have to do a change order. And
Yes.
change your 70-foot production length to something else. It
What do you
would.
find? What's this say?
Yeah, okay.
So,
So you can't stack them up on each one, okay?
yep. So that's why that's there, is for that reason, so there. We used to, in the old method, piling delivered, truck shipped, all the stuff, there was no maximum per splice. So then you get some contractors that would play the game and keep getting paid for a splice. So that's why that was added in. So relevant contract unit prices for piling include cost of repairing the piles for driving, that's, painting, galvanizing, whatever they want to do, pre-boring, jetting, placing the driving shoes. Again, we don't pay for shoes, right? The flat plate on the end of the CIP pile? No, we don't pay for that. It's not a separate pay item. We don't pay for the concrete separately for the concrete, the pile fill. We don't pay extra for cutting and trimming, and we don't pay extra for coating. That's all part of their bid pricing. So your bid items, CIP 12-inch piling, linear foot, 11,000 feet project total. So you have 4 test piles, 70 foot long, and 2 test piles, 100 foot long, 12 inch. Is there any cutting shoes on this project? Cutting shoes, comb. Look at your pay item list, your schedule of quantities. What does that say? Is there anything on there that says any special shoe? We don't pay for it. Okay? Nothing special, we're just gonna put the flat plate on you. How about a PDA? Okay? Pile redriving. So you have 14 redrives on this project.
I see
18? Okay? Any other questions? Well, we've covered about the specs. Remember, you don't have to memorize the plan, spec book, or special provisions. Just know where to find the answer when you need it. That's all I have for specs.
What's the list of logs over
The what?
there? The log list, the log?
That's coming up. That's coming up.
There's gotta be a list somewhere.
That's coming up. That's the next session, I think, or 2 sessions for forming. Clear as mud? Got her under control? That's your spec book. I guess we'll go to lunch till, is it an hour?
Yeah, hour lunch, so 10 minutes after we'll be back.
Is 50 minutes too short for lunch? Let's do 1 o'clock. Can we do 1 o'clock?
If we get 100% agreement.
Okay.